Defining constraints. There are 4 different kinds of constraints in SQL. A not null constraint, a unique constraint, a referential constraint, and a check constraint. Expressing constraint in SQL. There are 2 options. First one, column constraints, and the second one is table constraints. A column constraint applies to a single column and is written as part of the column definition when the table is defined. A table constraint is expressed independently of the columns as a separate entry in a table definition. Let us see examples here. Not null constraint. We'll see examples of not null constraint. Create table, table name, etc. Supply all the details here. So here you have to specify the end along with the column. So here you are specifying the column name and the data type. So immediately after that, you have to specify the column constraint. So it's an optional. It's not mandatory. If you want to give a column constraint, you can specify here. Example: create table textbook. We have seen this one, and it says that title varchar 40, and we are specifying a constraint not null because the title supposed to have a value always. We have the unique constraint, the second one. In SQL, columns are constrained to be candidate keys using the keyword unique. So, if we want to state that no 2 teams can be headed by the same doctor, we could write create team, supply all the attributes, and staff number is a column, and it says chart 3 and it is unique. So this should have only only one value, single value at each time, unique values. Unique constraints as table constraint. You can use unique constraint either as a column constraint or as a table constraint. Create table team, supply all the columns and the attributes, and you can specify the keyword constraint and give any meaningful name for the constraint. And what type of constraint we are using? We are using unique, and the column specified here is the staff number. Unique constraint as table constraint for multiple columns. So the say you can see here to create table textbook, and we have all the columns, and we have the keyword constraint and the constraint name, unique title, and we are using what type of constraint here? We use unique constraint. So unique values, title should be unique and the addition should be unique. These 2 values you can have only unique values in the table. Defining the primary key. In SQL Anywhere, primary key, unique, or you can say uniqueness and not null. In the relational model, we can have uniqueness and still allow nulls. Defining the primary key. So we have seen this example, how to create a table. Here you can see create table textbook, book called chart 5. We are specifying this as a column constraint primary key. So if you have multiple column primary keys here, the table we have created, which is a textbook, we had only one primary key. So you can specify this as a column constraint. Suppose you have multiple columns. So you can say create table and write down, say for example, you're creating the enrollment table here, and write down all the columns and the type. And you have to specify the keyword primary key, and the first primary key is student ID. Use a comma separator, and we have the course code. This is the second primary key. Referential constraints. Next one. The primary key of the reference table is usually used, but any column or columns can be used as long as they have a unique constraint defined upon them. For example, sorry, this is the syntax here. You can see create table, table name, and you have to specify the keyword constraint, and you can supply any value constraint name here, and you can see foreign key and foreign key or foreign keys, and you have to specify, use the references keyword and determine which table it is referencing. Example, referencing a primary key. Create table staff. The columns, we have the region number, small int, which is what, not null. So region number should have a value always. And the constraint, this is the constraint name, staff in contracts with, and we have a foreign key. Our foreign key column is region number, which references the region table. This form assumes that it refers to the primary key of the referenced relation. Referencing a candidate key, use the form foreign key, specify the column names, references, reference field, C1, the candidate's keys, etc. The columns F1, F2, etc., Fn are the foreign key. The columns C1, C2, Cn are the candidate key. A foreign key may have a null value. Referential actions. SQL provides 4 possible actions that may occur for a dependent row of a referencing table when the reference row is deleted. First one, restrict. Prevents the reference row from being deleted. This is the default. Second one, set null. Sets the value of the foreign key in the dependent row to null. Third option, set default. Sets the value of the foreign key in the dependent row to its default value. Last option is the cascade. Deletes the dependent rows. So once you delete, the corresponding rows will be deleted if you specify cascade. For example, foreign keys, specify the keys and use the keyword references, and you have to specify the reference table and the candidate keys. On delete, so this is the new keyword we're going to add for the referential action. So on delete is the new keyword, and what action you're going to use, either it is cascade or it is default, etc., like that. Example, while you create the textbook table, constraint textbook in used on foreign key course code, references course. On delete, cascade. Once you delete, automatically the corresponding values should be deleted if you specify the option cascade. Check constraints. In a check constraint, the condition described must not evaluate to false. So it must evaluate to either true or unknown. The general syntax to define a check constraint on a table is create table, table name, supply the column values, constraint is the keyword, and write down your constraint name, check, and give the condition. What is the condition you're going to specify? Check is the keyword used for the check constraint. For example, the number of a region must be integer between 1 and 99 in the region table. Assume create table region. So you can see region number is what? Small int. And we are specifying a constraint that region number limits is the name of the constraint. Condition is check what? The column name what? Region number between 1 and 99. 1 and 99. So we are using what? We are using a check constraint here. So the keyword used here is, because it says that between 1 and 99, you have to specify that particular column should be between 1 and 99. More complex example here. The student may not enroll more than 180 points worth of course at any one time. It behaves like a correlated nested query. This example, create table student, and we have the student ID chart3, and we have a constraint. The constraint name is enrollment limit, and we are using a check constraint, and check will evaluate the result of this query with assuming 180 greater than the result of the query. This should be what? This should be this is the total number of credits, total number of credits registered by the student. Select some credit will give you the total number of credits from enrollment and course table and the other conditions. Alternate constraint formulation. We can often choose the table on which to define a constraint, and the constraint may need to be written differently depending upon where it is defined. For example, create table enrollment. So here you have the constraint enrollment limit check 180 greater than. So we use the keyword all. Select some credit. So it is checking from all. It is checking all the details. 180 more than all the total credits. Using constraints. We can use a check constraint where another form of constraint would be more appropriate. For example, the following constraint defined in textbook table. Check course code in what? In where? See, it will, you're using a subquery. Select course code from course. So we'll give you the course codes column from the course table and checking that this course code exists in result of this. Implements referential integrity. However, where possible, we use a referential constraint rather than a check constraint because the referential constraint makes the purpose of the constraint explicit. A referential constraint can take advantage of SQL's referential actions. Go back to Sybase Central and see the contents of, for example, student table. So you can see in the column, we have one column constraint, which is the student ID. So go to the foreign key. So you can see here, region number is a foreign key column here, which represent which is the value, which is a column in the region. And go to the referencing table. So the referencing tables are enrollment. So we have the unique. We don't have any unique constraint. So we have check constraints here. So student ID column has a check constraint to make sure the values, the correct values are used here. And you can see the email address also. We have a check constraint. So it is making sure that it has an @ character. So if you go to your region table, again, you're able to see here, you have a column constraint, which is region, and you don't have any foreign key. You don't have unique. You have a check constraint for the region number. It is checking a value small integer between 1 and 12. And again, here we have a check constraint for the email address to make sure the email address has an @ character.